In this video, we will study the formal charge, what exactly formal charge is, and how to calculate it. In simple words, formal charge is the charge that is assigned to individual atoms in a Lewis structure. It gives clues about chemical reactivity. And by definition, formal charge corresponds to the difference between the number of valence electrons in the neutral free atom and the number of valence electrons in its bonded state. Neutral free atom means an atom is not bonded to other atoms. And we can calculate the formal charge by applying this simple equation, where formal charge is equal to the number of valence electrons minus the number of lone pair electrons, or we can say unshared electrons, plus the number of bonds. The group number indicates the appropriate number of valence electrons for each atom. For example, carbon. It is in group 4a. Therefore, it has 4 valence electrons. Nitrogen is in group 5a of the periodic table. Therefore, 5 valence electrons. Oxygen is in group 6a. So, it has 6 valence electrons. Hence, by inspecting the periodic table, the number of valence electrons in the neutral free atom can be determined. And by calculating the formal charge, we determine how the number of electrons around a particular atom compares to its number of valence electrons. Now we will see how to apply the equation. Let's calculate the formal charge on oxygen. Number 1 is water. Oxygen has 6 valence electrons minus the number of lone pair electrons. Oxygen in water exhibits 4 lone pair electrons plus number of bonds, that is 2, and therefore the formal charge is 0. Oxygen atom in water doesn't have a formal charge. The next one is the hydronium ion. Similarly, 6 valence electrons in the neutral free atom minus the number of lone pair electrons. In this case, 2 lone pair electrons plus 3 bonds, 3 covalent bonds. Therefore, the formal charge is plus 1. Number 3, the last one, hydroxide ion. In the hydroxide ion, 6 lone pair electrons plus 1 covalent bond. Therefore, the formal charge is minus 1. Now let's calculate formal charge of nitrogen atoms in each of these species. Nitrogen is in group 5a of the periodic table and therefore has 5 valence electrons minus number of lone pair electrons. In ammonia, it is 2 plus the number of bonds. There are 3 covalent bonds. Therefore, the formal charge is 0. The next one is the ammonium ion. The same way, calculate the formal charge, number of valence electrons minus number of lone pair electrons. In this case, 0. Nitrogen with 4 covalent bonds has no lone pairs plus the number of bonds, 4. If we calculate this, we will get plus 1. The last one is the amide ion. In this case, the number of lone pair electrons is 4. plus the number of bonds, that is 2, and this gives us -1 formal charge. These are the situations when atoms do not bear a formal charge. It will be always true that a carbon with 4 covalent bonds and 0 lone pairs has no formal charge. Nitrogen atom with 3 covalent bonds and 1 lone pair has no formal charge. An oxygen with 2 covalent bonds and 2 unshared pairs has no formal charge. Halogens with 3 lone pairs form 1 covalent bond, hence bear 0 formal charge. And lastly, it will be true that a covalently bonded hydrogen atom has no formal charge. Here are some problems. You can try this, and if you have any doubts, let me know in the comments below. And finally, the summary of the formal charges. It will help you examine each atom to see whether a formal charge should be assigned to it. So that's all for today. I'll see you in the next video.